What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at part 2 of our MatPlotLib tutorial series. So in the first video, guys, or in the previous video, essentially what we did is we looked at the basics, of the package itself, MatPlotLib. We were just introduced to the Python package and what it is used for. We also plotted a few basic plots, okay? Essentially what we did was plotting a single curve on a set of axes. So in this video, we will just explore, the more features and functions that Matplotlib offers us. So yeah, this is what we can do. So the first thing I'd like to show you guys is, so I will create a new cell here. First thing we will be doing is plotting multiple curves. So I explained to you in the previous video, right? I just gave you guys sort of insight, a quick example of how we have the ability, to plot multiple curves or gradients on a single Cartesian plane, okay, or single set of axes. Now, essentially, we learned about the plt.show method. So this is the concept that plotting multiple curves is going to use. So you see, one of the main reasons we plot multiple curves or many curves on one axis, you may ask, right, why do we do that? So one of the main reasons we actually plot multiple gradients or multiple curves on one axis is essentially to compare those curves. Okay, these visualizations are all about data, and so by having multiple curves on one graph, we have the ability to compare, what those gradients or what those curves are actually describing. Are they matching? Where do they match? Where do they not match? Are the curves correlated in some way or the other? Okay, it helps us to basically ask and answer questions, about the variables that we are working with. So let's actually get to it. We will be plotting simple graphs, just for demonstration purposes. So let me adjust the size of the plots pane. So now what we can do is import our numpy as np. Then we will do import matplotlib dot pyplot as plt. After this, we can set up the x values for the x-axis. So let's do a numpy.linspace, and we can put here 0 to 2 multiplied by numpy.py, and suppose we'd like 100 values. So that's that. Now what I can do is set up the y values, but remember, right, we want multiple curves on one axis or axes. So what we can do is I will call the first graph or first curve ya. So let's say ya, in order to get these values, what we can do is a simple numpy dot, let's do sine of x. And for the second curve, suppose we'd like y of b, and we can call this or set this equals to numpy.cos of x. So as you can see, we are going to work with a simple sine and cos graph. We will see these gradients or these curves on the same set of axes, on the same canvas. So let's do plt.plot. This is the first graph that will be plotted. So it's ya, then we can do plt.plot. We pass the x values, then yb. Now, after this, what we need to do is plt.show. So I will run this and we can have a small discussion about what we just did. So this is the code we have. I press Ctrl Enter. I give it a few seconds, and as you guys can see, I have these two curves. It's a sine and a cos graph that is plotted. Now, let's talk a bit, about the important stuff that is happening here. So as you'll notice, right, and I did talk about this concept in the first video, right? It is simple to understand, so we did cover it back then, but now is kind of, when we actually, doing a physical implementation. So essentially, the two curves that we have plotted here, the first thing you'll notice, especially in the visualization, is that they each have a different color, okay? Different curves will have a different color, and this is done automatically by MatPlotLib. This is kind of a default behavior of MatPlotLib. When it detects several curves being plotted on the same canvas, on the same, distribution, essentially what happens is that each curve will take on a different color, for, I would say, representation purposes. Now, you see, plt.plot, this is what is doing the plotting. Okay, we use this function plt.plot to basically signal the call for plotting or drawing one curve. So essentially, we would like to have two curves in this example on the same canvas. This is why we use plt.plot two times. We pass in x and then ya, and then we pass in x and yb. And as you can see, this is what we have, two gradients or two curves on the same canvas. Now, plt.show, right? It's very good to understand. I explained this previously. plt.show signals to Python and, Matplotlib that we are ready to display everything that we have described. Okay, and by described, what I mean is that you see the plt.plot, these lines of code here, this is simply sort of describing, what we want to plot. You see, in traditional Python syntax, what you'll notice is I have deleted or removed plt.show, right? And if I run this, essentially we get the same distribution. But now what I should mention is that in traditional Python syntax, right, if you did not have the line of code that was basically plt.show, if we omitted this line here and if we ran the script, what you would find is that nothing would actually show up. Okay, and it's because of the fact that in these lines of code here, wherever we see plt.plot, because we are plotting a line graph, so plt.plot is merely describing what we want. It is describing, it is not actually rendering. Okay, plt.show is what tells matplotlib that we would like now to show what we have just described earlier. So this explains now the usage of plt.show. Now, this concept of what we just described, it is known as deferred rendering. Okay, and that makes sense because essentially the plt.show is what kind of flushes all of those descriptions and transforms it into a visualization that is presented to us. Now, essentially, since we are working with a line graph, I should mention at this point in time that you have the ability to plot several types of graphs or, visualizations on the same canvas. You can scatter and draw a line graph on the same canvas. Okay, think of real life. We can plot a scatter plot and a line graph on the same Cartesian plane. Matplotlib uses the exact same logic, but it's just all digital. Okay, so plt.show is basically representing that piece of paper we are working with. Once I call plt.show, it kind of signals that, I am done using this piece of paper, and everything that is going to be described after will be plotted on a new piece of paper. So I hope that makes sense to you. Now, that is that. So it is interesting, if you will agree with me. So what else I can do is taking into consideration this concept of deferred rendering, right? So it is central to matplotlib. Okay, it's kind of defaulted behavior that is built into matplotlib. Now we can declare what we want to render as and when it suits us. We have the choice. Okay, if we would like to display a certain curve or a certain function or gradient at a certain point in time, all we have to do is call the plt.show method. Okay, that is our choice. So what I can also demonstrate is I can just demonstrate in a quick example another concept of deferred rendering. Okay, so we have the ability to basically define functions, and we can plot these functions as and when we would like to. So let me actually demonstrate this for you now. So I will go ahead and import again, since we are creating a kind of neatened matplotlib script. I described to you guys as well. All of these scripts will be really helpful for us, when we look back at this in the near future. So it will be our own sort of personalized documentation. So comment this out, just say a script to demonstrate the power of deferred rendering in matplotlib. So let's do another importation. So import matplotlib.pyplot as plt. So what I'd like to do now is just define a simple function. Let's say we call this plot slope. So I actually typed scope. So plot slope xy, that is the standard variables for any graph. Suppose we can say x's is equals to x 1 onwards minus x all to the negative 1. That's a simple slicing operation. Suppose we'll call this our y's. So let's assume the y's are maybe 1 onwards. It has to be matching, as I told you guys, in a distribution. And if I'm not mistaken, the way in which we learned this in high school as well was, for every x value, there needs to be a corresponding y value, and together the x and the y value will form a data pair or a data point. So this will be y, and again all to the negative 1. So that's the slicing operations. What I can do now is a plt.plot, and this is all happening within a function. Okay guys, keep in mind that this is a function that we are defining just to demonstrate the concept and the power that deferred rendering has, in matplotlib. So that's what we have there. For the x values, it can be x1 onwards, and for the y values, this is what we are passing to plt.plot. Suppose the y values we'd like to utilize is the y's divided by the x's. So that is the function. Now let's actually proceed to set up values for the x and y. So again, we do a simple numpy.linspace. I can do -3, 3, and 100. Now we can set up y. So for y, let's do exponent. Why not? -x to the power 2. Now this is what I have here. You guys can run this, have a look at what the arrays we are working with looks like. There are 100 values in x, and so there should be 100 values in y. So let's actually confirm that. As you guys can see, now what we can do is we are ready to plot. So let us test the concept of deferred rendering in matplotlib. I am passing in the first one that I'd like to plot a line graph x and y, which is this. Now in the second plot that I'd like to create, suppose I would like to have a plot scope. A slope. I am calling my function itself. Again, I have to pass x and y because I am utilizing these values here. It's just that within the function itself, the x and y values are undergoing some sort of manipulation. They are sort of being altered or changed, okay, the x and the y values, because of the fact that we have the slicing operation taking place, as well as the division, which is giving us the y value. So these two graphs will look different. Okay, all in all they will look different. As you guys can see, I just ran control enter. Essentially the graph shows, but I actually forgot to include plt.show. Plt.show is super important. Do not forget to add this line of code after you are done working with a canvas. Okay, so that is good. Just to give you guys more insight, suppose I had three, gradients that I wanted to plot. So essentially I can just maybe copy this and paste this here. So these are three gradients that I'd like to plot on the same canvas, so on the same piece of paper. Now essentially if I run this, you guys will see indeed it changed color, but the graph is the same. That's because the points here are sort of getting they are exactly the same, right? So that's why the line is a different color, but it maintains the same shape. But all in all, there are three graphs on this distribution that we see here. Now suppose I would like to have that third graph, separately on another piece of paper. Now as you guys saw, right, that graph was being called here, it was being called here, and after that plt.show was called. So it rendered everything that was described above, which is 1, 2, and 3. That those are the three distributions. Now as I said, suppose I wanted to have two distributions and that other one should be an individual. Now essentially what should happen, or what I should do, is after calling plt.show for the first sets of distributions that I wanted to plot on the same canvas, I can thereafter describe on a new canvas that I will have all of the functions or distributions that I'd like to have. So I would like to have this single one. So what I can do is call it or describe it, and thereafter I am done with that canvas. So a simple plt.show. And as you guys will see, I now have these distributions separated. So I hope it does make sense. If you will notice, I am kind of reinforcing the concept of plt.show. That is probably the most important concept to understand for MatPlotLib, especially when it comes to the rendering portions. Because what you will find, guys, is that when you work with large amounts of data, or if you're a data analyst, or a data scientist, or just if your daily job is to do with the dealing of data, visualization is most likely to be something that you do on a regular basis to get insight into that data. So if you are working with MatPlotLib especially, chances of plotting multiple curves on the same canvas is pretty high. So it is good that you understand the plt.show method. So that is good. Now I think for this tutorial, or for this video, this is where we will stop. Essentially what we covered in this video was the plotting of multiple curves on a single canvas, or on a single set of axes. So with that, we will end the video here. Thanks for watching, guys. Thanks for staying till the end of the video. Do make sure, to leave a like for the channel, for the video. Subscribe to the channel for more educational content. And I will see you guys in the next video. Good luck with your work.